well. That will not only reduce the computational time and efforts also. So we will get to understand in this session what are the tools that you can apply in the process, in the cycle of your model building. Then we will be covering the feature importance. As I said, key features what we have selected for our ML model. We will get to understand how and how we can get the importance of the features, and based on their importance, how we can select them for the providing the final output or the solutions. So these are the contents we will be covering with the hands-on sessions, where we will be trying to complete all the contents what we are discussing so far, right? So let us start with the feature engineering. Actually, what is a feature engineering? And before starting with the feature engineering, first we should try to understand what the term feature is all about. Features are like, you can say, the contents or the parameters that we have in our data set. So as we know that machine learning is starts when we have a huge amount of data with us. Based on that data, we will be able to develop an ML solutions, train our algos. So features are majorly one of the important parameters that present in our data sets that will help us out to develop any solutions. Now, if I'm saying that feature is a parameter that you can use to develop an AI solutions or the ML solutions, not all features are of our great interest, because um, majorly there are few parameters or a specific set of parameters are there or features are there that will play an important role in getting the outcomes. So that's why feature engineering is came into the picture, where we will be applying some of the statistical techniques, some of the machine learning techniques, and we will come up with specific features that will go in the process of developing the solutions. Here, selection of the features, and many of the times we will be creating the features as well as per the use case or the problem that you are trying to solve. The things are covered as per the requirement of the use case. So if in general terms, when I say about feature engineering is to find out the best impactful features that will help us to develop an accurate predictive models or the AI solutions. Why it is necessary? Because it will reduce our computational times. Because if, for an example, we will be uh, developing any AI solutions for the medical domain. So, if suppose you are making a model where you will be diagnosing the medical condition of a patient. So, in that solutions, maybe if in your data set you are holding the patient ID. So, patient ID is a feature that is present in the data set, but it doesn't make any impact, or it doesn't make any sense in when you are diagnosing the patient condition or the medical conditions. So how you will be able to identify that patient ID will not going to make any impact in the solutions? So for that questions, the answers will be through the feature engineering. We will come to know how the features are impacting. So if I'm saying my target or my outcome is the medical condition of a patient, so in that I have to identify which are the features are supporting to get me to the outcome. So that's the phase of the feature engineering, where we will select the impactful features. Those are contributing to the outcomes. So that's why feature engineering is an important phase. Now, when we start with the ML model, the very first phase comes with the data acquisitions. Then we always go for pre-processing the data, filtering out the data. So that is not sufficient for building an accurate model. If we want to go for making an accurate and best outcome deliveries through the AI model, we have to select the best features by applying the different techniques. So in the next consecutive slides, we will get to know how we can go for applying those feature engineering techniques, right? Now, this is a complete flow of our machine learning solutions. Now, always you can see here, we starts with, as I said, we starts with data acquisition. Here we will be collecting all the data, what is required for our use case or the problem statement on which we are working. Here, once all the data has been collected, the very first thing that we do is the data pre-processing. Why the data pre-processing is, we need the to pre-process the data because the data is collected from a number of resources. The structure or the uniformity or the consistency may not be there. So here we have to take care to pre-process the data where we will be dealing with the missing values, um, the consistent uniform pattern we will have to do. We need to normalize the data. So in the data pre-processing sections, we will be taking care of all the data filtering tasks, processing tasks. So the data pre-processing, we are not supposed to discuss here, but once the process data is with us, the major important task is the feature extraction and engineering. I can tell you, like, if we have not done the feature engineering in the correct way, your solution cannot be on the perfect side because it is the important section. Like what I've taken an example, if suppose our features are not selected in the correct way, then you will never get the solutions on the correct side. So it doesn't matter which algos we have applied, deep learning or ML, that will not work out unless until you will apply the best and correct features for your model. So this is the important phase. Now, how we can say that key feature engineering is the important thing. Now, these are certain points what I have mentioned here. Now, through this feature engineering, what we are going to do is we will be uh, preventing our outcomes to be on the wrong side. Like whatever the misleading outcomes, if we are getting out of the data, so that can be avoided if we have selected the correct features for our model building. Along with this, we will get the desired and necessary dimensions only with us. Dimensions in the sense features with us through which we can get the solutions. In this, we will be dealing with the outliers as well. Outliers means you can say those data points which will be giving a negative impact on our model building. So negative impact in the sense, for an example, if uh, we will be we continue with that example. Like suppose we are making a solution for mm, medical domain for the diagnosis. So if we are we have a data set where uh, by mistake or typo error, if we have entered the age of a patient, let's say in minus or decimals. So if you are making such entries in the data set, so that can be considered as outliers because they will not contribute in the outcome. They will mislead our outcomes because the data was not correct. So obviously, the results what we are expecting through the solution will never be going to correct. So that's why outlier handling is one of the things that we need to take care in the feature engineering. Now we have this. I've told you lot main why it is important. What are the basic important role of feature engineering? Now there is so many methods or ML techniques are there that we can apply to get the best features select out of it. But the one more thing is the knowledge of the domain is also very important. Now, how we can say that? Now, for an example, like when we talk about in terms of data science perspective, what we do is we generally apply the algos that are available or the statistical techniques to get the correct features. But maybe what features we have come out after we have collected after the feature engineering that will not relate with the domain. Domain that means, for an example, like see, I'll tell you the basic what we are providing, right? So industry 4.0 solutions, let's talk about it. In industry 4.0 solution, what happened is the knowledge of the domain is very important, not in specifically in industry 4.0, in any of the use case or ML model, whatever we are delivering. The domain knowledge is very much just required. Why? Because whatever the solutions like say supervised or unsupervised, what are the techniques we are applying to develop a model, we have to validate it because ultimately we are delivering it to get it utilized in the real world. So if you are providing a solution, let's say I'm building a model where the refineries can perform better, they can run for more number of days. If I'm supposed to deliver such a solution to the industry, and I don't know anything about the refinery, how the process are going on, how the critical things are going on. So our solution will not relate it with that concept in any ways. So that's why the domain knowledge or the use case on which we are working, that is important because that is a pure blend of the domain plus the data science techniques. So you can say vice versa, both are applicable if we are looking for the accurate solutions, right? So these are the important things that we have to consider in the feature engineering. So we are talking about these sections. Now, in the feature engineering, we have to go for selection also of the best feature or to scale them. So that part also is included in feature engineering. So this is the phase where we are preparing the data. Now I can say in the whole life cycle of the model building, ML model building, we are spending almost 60 to 70% of the time on data preparation. Why? Because this is the most important section, because this is going to be an input to your model. So this is a very critical sections where we need to take care of getting the best features, because if the inputs are not on the correct way, the output we are not able to get it on the right side, right? So in the data preparation now, as all the life cycle covers building an ML model, their evaluations and the deployment, these are the different sections. But we need to concentrate on how we can go for getting the best feature out of it, right? Now today what we will be covering is way of the feature engineering techniques, where we'll concentrate on what the label encoding is. That is all in the hands-on session we will be taking. How we can go for label encoding techniques? Label encoding in the sense like if we have a categorical values like in the characters. So if we want to go for applying any of the ML algos, we need to encode it into some numeric values, or we can assign them certain code numbers. So that means the label encoding is one of the way where you can deal with the categorical values, so that you can go for implementing the ML algos and go for a classification or regression, whatever is desired. So through the practical, we will in the hands-on session, we will see how we can utilize this label encoding section. Then we have a bucketizations using pandas. Here we will be concentrating on how we can group number of data points present in the data set. Why it is required? Now, let's understand what is the requirement of this creating a bins from the data set. Because if we are dealing with a large number of data set, if we will group them into specific ranges, so it will be easy, or you can say the efficiency of the model can be increased. If rather than dealing with the individual data points, if we will be dealing within a group or a range, so that will be easy, or you can say the performance of the model can be increased. So that's why the bins are created. And it's a part of your feature creation, you can say, because feature creation, how it is, because if we are creating a group of, let's say, uh, some processes we are going to group it all together in different ranges. So that means this is a new or unique feature you are creating that is not present in your draw data set. So here we will be using. Then we have a correlation of how the correlation is helping us in this sense. Correlation, that means where we will try to identify how the different parameters or features are relating with each other. So if, let's say, if I'm saying uh, age of a patient is how much it is relating with a particular disease. So if I want to check it out, how much they are related with each other. So this correlation technique will help me out to understand, is this really true? Like if I'm saying both having 80% of correlation, it means yeah, this is true through the technique, correlation technique. If the age of a patient on the higher side, definitely the disease is on the he is on the higher risk sector, right? So the correlation is simply to get understanding of it, how the parameters relate with each other. We will get to know by applying the correlation techniques on the data set. Then we will be covering the outliers. As I said, the outlier is identifying those data points that are not significant for your model building. Those maybe create noise to your data set, that are maybe some uh, inaccurate observation that has been recorded. So before starting with the model building, we need to remove or drop it out all the outliers those are present in the data set. Now I'll include one more point here, because outlier, as I said, the domain is very important here. Now outlier, what I can say is, for an example, if I'm saying that I'm making a solution for the process industry, for the refinery, if I'm saying that my temperature is going around something about 20 to 80, this is the range. What I can see in the data set, almost minimum and maximum range, it is follow 20 to 80. Now somewhere it is coming around 10, 15. These are also the ranges I'm getting. So when I look from the data science perspective, this is the outlier for me. But maybe this is maybe some abnormal condition that occurs in the real environment that has been captured by their devices. So we need to take care if we are working on outliers, both the things should be considered. It's not all about looking at the data set. We have to consult with the domains as well. Yeah, if the ranges are like this, so is it really on the um, um, inaccurate observations, or it actually happens in the real environment? So this things is very much related with the domain. So uh, why this discussion is very important, because when we theoretically think about the models or ML model, nowhere we will be get to know about these insights, because we only have been taught about what are the techniques, how you can implement it. Outliers means just drop out the data points. So it will not be like this in the real sense. If we are looking for the outliers, we have to focus on what the specific real time observations are there. So these are the important things. Okay. Now, the tools that we have been covering is two tools today we will be going to cover. That is the feature tools. This is just a framework that will minimize our efforts for extracting the features, because this will provide us multiple methods and functions through which we can automate the feature engineering process, right? So through this feature tools, we will see how we can reduce our efforts, and with less span of time, we can get the best or automate the feature selection process. Second tool that we will be covering is PyCard. This is, you can say, it's a really good tool where not only right from the feature selection till the evaluation of your model, it is going to cover all the cycle of your ML model development. So this is one of the wonderful tools where you can explore it. It will give us the flexibility to select the features, evaluate your models, and just compare it with the other helpers. So this we will be covering. Then next we talk about something about the feature importance and selections. So feature importance and selections, where we will try out to select the best features that are necessary for getting the outcomes. Here we totally concentrate on reducing the noise or the abnormal observations that is there in the data set. So we have multiple techniques through which we can check it out what are the important features with respect to the target or the outcome what we are looking for. So these are some of the things that we will be covering. So this is we will more focused on the practical or the hands-on sessions. This is just an overview I have given you, like what is exactly important for the feature engineering and what else we can do, or what are the tools which are important for the feature engineering, right? So let me jump onto that session. Yeah, let's start with the um, very first part. Now, first we will be see all these. First, we will see how the feature extractions can be implemented, as we have seen the outline of the methods or the things that we can apply in the feature engineering. Now, first of all, we will get see how we can go for label encoding and exactly why it is important. Now, as you can see, label encoding is one of the way through which we can give codes or the numeric value we can assign to any of the categorical feature. Why? Because in the ML, if we are going for regression algos, there we specifically need some numeric values that need to be scaled up or to get the classification or regression. So at that moment, we need to encode our features. Now, in this example, this is some Kaggle data I'm using here. We are just reading it out here. Collabs I have created because it's very easy that you can also practice without any installation on Python. So in the collabs only, I have created a notebook. So this is just freely available data on the Kaggle where I have utilized it. And this is just to demonstrate you how we can go for label encoding. Like uh, if I'm having a data set where multiple education degrees have been given. So if I want to make any model by taking these education degrees or the qualifications, so that will not be possible because this is a categorical data. So there is certain limitations of it. So we definitely need to convert it into some of the numeric values. So through the sklearn library, we have one of the feature that is called as the label encoder, where we can convert all our these categorical parameters or values into the numeric values. Now you can see we have just simply implemented the label encoder function through the sklearn library, and you can see each one of the education or the qualification has been assigned a unique number. Now this maybe without the help of this sklearn library, we have to go for manually doing the same thing. But here, through the label encoder, we will be just implementing it and we are getting the solution out of it by providing a unique numbers to them, right? Now, uh, through the label encoders, what else we can do? Now, see one more example I have captured here. Now, here what we have to give, if in case, now through the label encoding, what happens is we will be at random assigned some numbers. Okay, so in case we want to prioritize some of the degrees, so if we will want to go for mentioning like for doctorate, if we want to go give the highest rankings or the priority numbers. So how we can go for assigning the labels so that when the result or the labels will be created, numeric one, the priority numbers will be assigned. This will not be any you can say random numbers will be assigned to it. So this we can go, like you can say here, in the previous example, we have not created any labels. We have just applied the label encoder and transform it. So random numbers has been assigned to it. But here specifically, we will be giving certain priority numbers to them, to each one of the qualifications, so that when it comes up in the form of numeric labels, it should be according to the priority what you have set. So this also we can do. So these are the two ways through which we can label our categorical features, right? Now the second thing what we have discussed, key creating the bins. or we need to bucketize our data set in certain ranges. Now let's first see the what we are getting, then we come up to the code section, right? Now here you can see the data is there. See the data where we will be having multiple age groups. Age are there, qualifications are there, some of the occupation and general things are mentioned in the data set. Now, what we have done is we have first identifying what are the age ranges are available in the data set. Now you can see here, this is the distribution of age parameter. Now looking at this distribution, if I want to group them into certain categories, right? So let's say the categories will be like one, two, three categories I'm making, and certain ranges I want to define for this. So we can go for creating the bins of the particular feature that will help us out to reduce the dimensions, to reduce the individual data points, because we are grouping them all together in three different categories, right? So how we can go for it? Through creating the bins, we can do this. As you can see, this is the very important section. So what the three categories what we have created, these are the three categories. Now, three ranges of the age group we have selected. So here we are writing a function through which we can define the range set for three different categories. And based on that, we'll be creating the bins, means three different categories with three different age groups that we are creating here, right? So see, these are the all the things that we are discussing. It's somewhere when we are in the phase of data preparation, these are required. The will you go ahead with these techniques, the methods, the better the outcomes will be, right? So these are the important things that we can get out of it. Now the correlation, what I'm talking about, the correlation, that means how we are relating, the parameters are related with each other. Now looking at this correlation is against the parameter age. Now, if I'm saying that key age is an important target, this is the target for my model. Now, if I'm looking for the age, that means what is the very close correlated parameter with age is this is the education, okay, or the capital gain. These are, I can say, these are the top two positively correlated parameters. So simply in a very easy way, we can say that as my education is on the higher side, definitely my age is also on the higher side. If I'm saying my capital gains on the higher side, then definitely the age is also. That means these are positively correlated parameters. So this will help us out. This is one of the criteria which you can use at the time of selecting the parameters. So we can pick around positive parameters that will give us the accurate outcomes. Right? Now the outliers, let me cover one outlier point also. So in the outliers, what we can see here, we need to observe how the outliers are present, or what are the negative observations in our data set. Let's see one of the feature here. This is one of the presentation. Now you can see here education. Now education, you can see these are some of the data points or the observation that is coming in these sections. That means right from 0 till 5, whatever be the values are coming in the data set, these are all your outliers. So through the data science perspective, if I want to proceed for the model building, I will definitely drop all the instances or the observation, those are holding the value from 0 till 5. Why? Because these are the outliers. So this study indicates that these are not contributing in any sense to the outcome. So this is the way we will be handling the outliers. Now, this is just as an implementation, how we can go ahead with all these. I think will be available. All these notebooks will be available for you to access. You can go through it. Here we will majorly try to understand what exactly the techniques or the methods we can apply, right? Now, in this feature extraction, what else? Like most of the time when we are talking about the feature engineering, we only talk about the general contents, what are available, what are the methods, what are very generic things we are talking about. But multiple new tools are there that we can explore and get the best understanding out of it. Let's just talk about the feature importance lab. Now, as I said, key feature importance is one of the thing where we will get to know how important the feature are. Means out of n features, what are the x specific feature those are contributing to your target. So here we will use some of the very unique libraries through which we can go for finding out the feature importance, and then we can select it, right? So I'm using here shape library. So and then we can just see how we can utilize it. Now here in the first phase, I just simply call all the dependencies, the libraries that are required for the feature importance and selections. Now this is one of the real-time data set I have utilized. This is from some process side, some industry data set. What we have captured here, we have captured some of the critical process parameters, and we want to identify how the target uh, can be achieved or what features can be contributing for this, right? So let's start by the important factors, right? Now let's see here. Now see, what we are doing is we have a set of features with us. Now we are just separating out the target and the features so that we can identify if I'm looking for achieving the target or the outcome, what are the important features for it. So let's say X is having all the features with me, and Y is my target, what I want to achieve or want to predict it, right? So for this first, what I'm doing is I'm just implementing, I'm just splitting the data set like test and train. Why? Because if I'm looking for predicting the target, so I need to make two data sets. One is for the testing, one is for the training data set. So I'm just splitting it out altogether. So this is just the two splits I have created out of my uh, features and the target. Now, what we are focusing here is specifically this feature importance. How you will be able to identify what are the contributing features in this. Now you can see through the shape, this all the information is giving us a very good idea. If you can see this code, this DS ratios, this feed temperature, these are the very highly positively correlated features with the target. So through this library, we will get to know how and if I'm making a model, so you can definitely go ahead with top 5 features. We can include it in our model and we will get the very accurate prediction out of it. Unnecessary, we will not going to include all those parameters. Those are very less correlated. We are not important for the model prediction, right? Through through the SHAP, we can go ahead with this. What else we can get achieve it? Now see, I have included here different techniques for the feature importance. You can go through with this as well. Now we will be seeing what are the different methods. Now let's see, one more impactful thing is I want to show you this one. Now see, what we are doing here, we have a set of test and train data set. Now here we will suppose, for an example, we are looking for the target prediction. Now for the target prediction, looking at this image, we can understand these all parameters, let's say feed temperature 1, feed temperature 2, cot, this wall fuel, these are the very contributing parameters when we are talking in terms of predicting the target. Now, not only on the theoretical perspective, we are talking about what are the important features. We can see, and we can see the visualization also. It will help us understand what are the important uh, features that we can go ahead with this. What are the contributing parameters for our model building? So SHAP is one of the important library that you can explore, and this will be a base for selecting the features for our model, right? So we have seen two things for feature extraction and feature importance. Now I think this the time is also we are lagging is less. We see one of the important tools. Now, this will help you out definitely in terms of building the model, right? Let me show you this one. Now, Packard is one of the important tools that is available. Through this, we can get all the, we can see we can complete the whole machine learning life cycle through this single tool that is available to us. Like you see here, let's just start exploring this. Now, through this Packard tool, what we can do is we very minimal code is required. Just we need to set the target, what we are looking for, and provide the data frame where the data resides. It will automatically bifurcate all your training, your testing data set, all the information it will give us in a single click. This is the very best feature you can say. So you can get to analyze the whole data set in one shot. Along with this, it gives us the flexibility to compare all the baseline models. Now you can see I just called the compare model function here, and it is giving me all the models. So you can see so many algos are there, and it is giving me the comparison, which algo is the best if I'm looking for developing a prediction model. Now let's say this is the best algo I have received through my Packard library or the tool. So I simply go with this algo only for prediction of the model. Now, taking that algo for your model building, I have created my own model. Now you can see these are very predefined functions that is available in this tool. We just need to call it once and get ready with the model. It will reduce all your manual work, right? So my model is created. Now, if I want to increase the accuracy of the model, I can go for hyperparameter tuning as well. We can simply go need to go for defining what are the number of iterations we need to go. So this is defined here. Now you can say your accuracy has been also increased if we go for hyperparameter tuning. Through this tool, you can see the last, I'll show you this one. Now see, these are the model evaluation content. Here you are in one go will evaluate your model. key, what are your residuals, what are your feature importance, what is your feature selections in this model is present. So all the things in one click is available, that in the manual sense we have to go for writing a code for it, and then we will be getting the results. So through this tool we will get to understand and evaluate also our model. So this will be very uh, quick, and spontaneously you can go for developing a model, and it will reduce your efforts also for writing the code. So this is one of the tool we have to cover. So almost like important points and things we have covered. So I will be all my stuffs also like can be available. So is there any queries or any questions anybody have? Like we are trying to complete major things along with this. So please you can ask, like I need to wrap.
Yeah, before we go on to the question section, I would like kindly like to request everyone to fill up the feedback poll as it helps us to do more session like this. So, Surabhi, there are few questions. I can see that there are few questions in question answer section.
Okay. Yeah. Yeah, let me start with Industry 4.0. Actually, Industry 4.0 is one of the area where the data science is playing a vital role. Like why the data science and AI is a boom nowadays, because every industry, like right from the refineries, oil and chemical industries, in pharma, everywhere the AI is taking place over there. So industry 4.0 solution, that means when you are going from the manual process to the whole automized or digitized phase. So that is the industry 4.0 evolution where AI is playing an important role. So, in generic terms, what you can understand, Industry 4.0, where we will be digitizing or automizing all the industries, irrespective of their sectors, right? So, that is the Industry 4.0. What else? Yeah, features in naive Bayes classifier or any other ML classifier. Yeah. See, in the classifications, definitely we can define our own inputs. We can create the features as I as per the use case. We can create our own features, because not always we are available with required features. We can have we can you can synthesize the values, you can synthesize the features as per the requirement. So irrespective of the algos what we are implementing, whether it can be a classification or regression, yeah, definitely we can create features and take it as an input. See, features and parameters, like features, when we are talking about, those are present in our data set that we are picking up and developing a model. Parameters, when I said key parameters, generally we say actually in the process industry, we parameters is the generic term we apply on features. So it's not an issue. We vice versa, we can use features or parameters. It's one of the thing where those are contributing in the outcomes, right? See, feature selection is biased, or to handle that all such situations. That's why we have overfitting and underfitting concepts with us. So, to make this will not happen while the process we are doing the model building. We can go for identifying the overfitting and underfitting situations so that our data can be normalized. That's why the thing is we will check the distribution of our data set. And if it is not, then we can go for normalizing it. So if we will handle that thing in the data preparation stage only, so such solutions will be on the accurate side only. So as I said, multiple things are there, but uh, what problem you are, what the solution you are building, it depends on that. Yeah, definitely. For if you're looking for creating a features apart from the data set that are available, so that's what we started with feature tools. This is one of the data frame where we can create your own features. There are multiple methods and functions available that will help us out to create the features. So definitely feature tools you can explore. This is the data frame through which we can create features multiple. Yeah, it's correct. The answer what David has given. The instance and the feature, definitely feature is we are talking about the column or the data column, and instance is a row when we are talking about a single row or the instance where we include all the features but one single record, to be very precise. See, feature engineering like algorithm classification also we will be using for feature engineering. The first concept is in the feature engineering, the thing is data preparation is one of the mandatory thing, selection and creation of the features. What the use case is all about, whether you're going for regression or classification, that is the next phase where we will be trying out ML or deep learning algorithms. So that's the thing, right? Let me explore the questions. Yeah, I'll share my notebooks. Let me answer this one. I'll just explain. I'm just giving my GitHub repository. I will upload all this content on this, right? So this is the repository. You will get these all the stuffs available there, so that will not be an issue. Okay. So any other for any other queries, you can connect with me. So thanks to everyone for such a lovely sessions interacting with all you. That's my pleasure. Thanks. Yeah.
Thanks a lot, Survi. Uh, on behalf of Analytics Vidya, I would like to thank you and your time for delivering such a wonderful session.
Thank,
And I'm sure our audience also found it insightful. And hopefully, we can conduct such more sessions in the future with you.
yeah. Sure.
So, I hope everyone has filled up the feedback poll. And if not, can you please do that soon as we'll be wrapping up the session? And if you wish to conduct a webinar or are facing any difficulty in registering, connect with us at datahour@analyticsvidya.com, and the recordings of the session will be available within 2 days on our YouTube channel, and you can find the link in the chat section. And we'll be back with another data hour session tomorrow. And the links of the upcoming sessions are also in the chat section. Till then, bye bye and keep learning.